Welcome back to CIT 157 Module 6-3. In this module you will practice how to divide a network into small subnetworks. Read these carefully. Prerequisite is, you should know how to convert binary number to decimal. And also you must know how to identify IP address, network address, broadcast address, network portion, net ID, host portion, host ID, network mask, and available IP addresses. Review these if you do not have confidence. In this activity you will get the concept of subnet. Suppose that 100 of ID, I just use ID instead of IP just for example, numbers is the smallest number can be assigned to a group. Suppose that you have 7 small different groups in your company. Each group has less than 10 computers. The biggest group has 9 computers. Question: how many numbers of ID do you need? The answer is 100 x 7 equals 700. You need ID numbers for your company. How many do you use out of 700? The most, you may use 70 ID numbers because the biggest group has 9 computers. Others may have less than 9. How many do you waste? At least you waste about 630 IDs. If you apply the story to the real IP address, the smallest numbers you have to assign to a group is 254. A Class C network. If you have less than 254 host computers, you may waste IP addresses. What is the problem? There are so many computers want to use internet. So public IP address is limited. The IPv4 numbers are running out. To solve this wasting issue, we tried to use subnet, supernet, private IP address, and CIDR. And finally IPv6, which uses 128 bits, was introduced. This is an example of how to develop a system for subnet. Suppose that you have a group of numbers range 0 to 99. If you are required to make 10 groups in the range, same size in each group and easy to recognize each group, then how would you divide each group? This is the way what I would do. 1. Put all numbers in 2-digit format. 1st digit and 2n digit, for example, 01, 02, 03, 04, 98, 99. 2. Use 10 as subnet mask as a rule. The position of 1, which is first digit, will identify which group the number is belong to. The position of 0 will, which is second digit, will identify the number among the group. Subnet mask is 10. Loot at the table. A number 21 is belong to group 2 and its own ID is 1 inside group 2. Another number 91 is belong to group 9 and its own ID is 1 inside the group. Activity 2. Subnetting IP address. Subnetting is breaking a major network, from class A, B or C, into smaller subnetworks. Subnetting allows you to create multiple logical networks. If you do not subnet, you are only able to use one network from your class A, B, or C network address. Public IP addresses are limited. So without subnetting we may waste so many IP address. In an octet, 8 bits, if you use 1 bit for subnet, you can have 2 groups of subnetworks. It means the subnet mask is 10 million because we use first bit for grouping bit. In decimal, the subnet mask is 128. Look at each group has its own network address, broadcast address, and 126 useful IP addresses. If you use 2 bits for grouping, you will create 4 groups of subnetworks. Subnet mask is 1100,000 in binary and 192 in decimal. First 2 bits for subnet, and the rest 6 bits will be assigned for hosts' computers. There are total 64 IP addresses for each group. If we exclude network address and broadcast address, then 62 available IP addresses. You can see each group here. If you use 3 bits for grouping, you will create 8 groups of subnetworks. Subnet mask is 1110,000 in binary and 224 in decimal. First 3 bits for subnet, and the rest 5 bits will be assigned for hosts' computers. There are total 62 IP addresses for each group. If we exclude network address and broadcast address, then 30 available IP addresses. If you use 4 bits for grouping, you will create 16 groups of subnetworks. Subnet mask is 1111,000 in binary and 240 in decimal. First 4 bits for subnet, and the rest 4 bits will be assigned for hosts' computers. There are total 16 IP addresses for each group. If we exclude network address and broadcast address, then 14 available IP addresses. If you use 5 bits for grouping, you will create 32 groups of subnetworks. Subnet mask is 1111,000 in binary and 248 in decimal. First 5 bits for subnet, and the rest 3 bits will be assigned for hosts' computers. There are total 8 IP addresses for each group. If we exclude network address and broadcast address, then 6 available IP addresses. If you use 6 bits for grouping, you will create 64 groups of subnetworks. Subnet mask is 1111 in binary and 252 in decimal. First 6 bits for subnet, and the rest 2 bits will be assigned for hosts' computers. There are total 4 IP addresses for each group. If we exclude network address and broadcast address, then 2 available IP addresses. Activity 3 Examples of subnetting. In a network 204.17.5. 0 with Class C natural network mask 255.255.255.0, there is only one network. Network address is 204.17.5.0. First useful address is 204.17.5.1. Last useful IP is 204.17.5.254. And broadcast IP is 204.17.5.255. There are total 256 IP addresses, and 254 useful IP addresses. In a network 204.17.5. 0. Request is that 2 different networks, and less than 100 hosts each group. If you use 1 bits, it is satisfied with 2 different networks. That case, each group has 126 useful IP addresses. So it is satisfied with less than 100 request also. If you use 1 bit, the subnet mask is 10 million in binary, 128 in decimal. For full subnet mask, its default network mask is 255.255.2555.0, which you don't have to worry. And just add 4th octet subnet mask portion. So full subnet mask is 255.255.255.128. Look at slide for more specific IP addresses in the network. In order to subnet a network, extend the natural mask using some of the bits from the host portion of the address to create a subnetwork mask. It means some host portion is now considered as net portion. As the result, 1 bit of net portion is extended from host portion. In natural network mask, net portion is clearly identical in both decimal and in binary number. In subnet mask, net portion in binary is clearly identical for each group. Decimal numbers do not show this. Look at next slide for more detail. Activity 4 Practice subnetting. Follow this practice with paper and pencil. This is the answer. This is another practice. This is the answer. This is the end of module 6_3. In this module you have practiced subnetting. It is very important topic to understand network. I will see you in next lecture.